Now we're on page 105, and we are factoring trinomials, okay? We're factoring trinomials. So if you want to title it notes trinomials, A equal 1, that's what you can title it, but it's also all 3B.1. So it's still 3B.1, but we are factoring trinomials, okay? We're going to do when A equals 1, and then we're going to have it when A doesn't equal 1, okay? And a friendly reminder is if I can't factor it, it's called a prime. Okay. What we're focusing on are quadratic trinomial standard form. So we're going to be in the form of ax squared plus bx plus c. Y'all remember that? The quadratic standard form, ax squared plus bx plus c. Okay. So in our first box, you're going to write down b squared plus 7b plus 12. Okay. So we have b squared plus 7b plus 12. When we look at these numbers, with these terms, they do not have a GCF, right? There's no GCF. There's nothing for me to do there. I'm like, oh man, what am I going to do? Well, this is a unique situation. It's called a quadratic. And therefore it's quadratic because it has the same variables and the highest power of that variable is a 2. Okay. So it's a quadratic trinomial. This is our A term, our B term, and our C term. With your C term, you're going to list out all the factors that make up C. So factors are what numbers multiply to give me 12, right? So the factors would be 1 times 12, right? 2 times 6, and 3 times 4. Okay? What you're asking yourself is, of these factors, what will add to give me my B term? What will add together to give me my B term? So these are my options. My B term is 7. What adds together to give me 7? 3 and 4, winner, winner, chicken dinner. 3 plus 4 equals 7, and 3 times 4 equals 12. So therefore, my factored form is b plus 3, b plus 4, and now I have created a factor. Instead of having monomial factor, we now have binomial factor. You should. I told y'all, we're just gonna pretend that it's new though. I've accepted my fate. Okay. I wanted to say that you should have done this in Algebra 1, but we're pretending it's all new, so it's okay. All right, how do we feel? It wasn't bad, right? Are you ready to try another one? Okay. I write the branches. I call it the branch method because I create branches from my B and C. Do you have to create the branches? No, it just helps you know where I'm focusing on it. Okay. The right side is my work in my brain. So what's happening in my brain? My brain's saying, okay, what multiplies to give me 12? Boom, 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 boom. Okay. So the amount of work you write is 100% up to you. Let's try box number 2. In box number 2, you're going to write down t squared plus 12t plus 35. So you have t squared plus 12t plus 35. Okay. In your brain, you're asking yourself, okay, what is my c? Well, my c is 35. What are the factors of 35? Well, the factors of 35 are 1 and 35, 5 and 7. Of these factors, which will add to give me my b? And my b is 12. 5 times 7. So just to check, 5 plus 7 equals 12. 5 times 7 equals 35. So my binomial factors are t plus 5 and t plus 7. Oh. So guess whose turn it is now? It's yours. Oh my gosh. Who knew it? All right. So you have z squared plus 5z minus 24. So you have z squared plus 5z minus 24. Find its binomial factors because there's no GCF, right? So now we're going to see, is there a binomial factor? Okay, let's talk about it. So our goal here is negative 24. So I start off with 1, which means this has to be negative 24, right? I also could have negative 1 and positive 24. I could have 2 and negative 12. I could have negative 2 and positive 12. That's what we're looking for. I could have 3 and negative 8. I can also have negative 3 and positive 8. I could have 4 and negative 6. I can have negative 4 and positive 6. Did I miss any? Okay. And my goal is to become a 5. Out of all of my options, which two digits together will add to equal 5? Winner, winner. Negative 3 and positive 8. So negative 3 plus 8 is positive 5. And negative 3 times 8 is negative 24. So therefore, my binomial factors are z minus 3 and z plus 8. And bam, we did it. How you feel? Okay. What we call these are simple trinomials. They're called simple trinomials because your leading coefficient is a 1. Makes it simple, right? Well, what happens when it's no longer just 1? It's no longer simple. Okay. That's what happens. Okay. All right. So we're going to talk about what if there's other things there? What do we do? Oh no. Okay. So here's our example. We have 2x squared. This is your box 3, 4. We're going box 4? Yeah. Box 4. So we have 2x squared minus 18x plus 28. Okay. And I'm like, oh, it's not simple. But what does it say to do on the right-hand side? Always check for GCF first. So before you panic and think it's not simple, ask yourself, is there a GCF here? And the answer is yes, there is a GCF, and that GCF is 2. I can divide everything by 2. So when I divide everything by 2, it becomes 2x squared minus 9x plus 14. Dividing everything by 2 now turns it back into simple. Did we see that? So I'm going to ask myself what multiplies to give me positive 14, but adds to give me a negative 9. So what two numbers will multiply to give me 14? And remember, if you have to list out your options for 14, you always can, right? So 14, we have a very few options. We have 1 times 14, and we have 2 times 7. Okay? 2 plus 7 gives me a positive 9, but I need a negative 9. So that means that they would have to both be negative. Does that make sense? So now negative 2 plus negative 7 equals negative 9. And negative 2 times negative 7. A negative times a negative makes a positive. Works out. So you see, remember you had a GCF? That GCF is part of now your binomial factor. So it's going to stay. So I have 2 times x minus 2 times x minus 7. And this is my factored form. Questions, comments, concerns? All right, your turn. So in box 5, you have 3x squared plus 6x minus 9.
Doing it prime. Do you see how it is?
It's a prime, and what's it?
Uh, well, if there's not yet this prime, uh,
Then you would leave how it is. But
the wondering.
you should be fine on this one. Remember, it's a negative.
Oh, I'll get it.
Yeah, it's a negative. All right. So there's a GCF, right? So I'm going to divide everything by that GCF, and the GCF is 3. So it looked like it wasn't simple. It actually is. So we have 3x squared plus 2x minus 3. So we're asking ourselves what multiplies to give us negative 3, but adds to give us 2. Okay, well, there's not many combinations to get negative 3. So it would be a positive 3 and a negative 1. 3 times negative 1 is negative 3, and 3 plus negative 1 is positive 2. So your binomial factors are x plus 3 and x minus 1, and it doesn't matter the order you write them in. You could have written x minus 1 first, wouldn't have mattered. Okay. All right. In our last box, we have negative x cubed plus 3x squared plus 10x. All right, we're going to talk about this one. So we previously said that if your leading coefficient is negative, what does that make your GCF? It makes your GCF negative. If your leading coefficient is negative, then your GCF is also negative. So we have negative. This time, we don't have a numerical GCF. We have a variable GCF. Do we see that? So my variable GCF is just x. So we're dividing everything by, well, we do technically have a numerical. It's negative 1. Negative x. So GCF on the outside, quotient on the inside. We're left with x squared plus, not plus, you see nothing, minus, because positive divided by negative is a negative, minus 10. So the only difference between this example and the one before was that we have a variable along with our GCF. Do we see that? All right, now we ask ourselves what multiplies to give me negative 10, but adds to give me negative 3. What are my magic numbers? Mhm. You are perfect. Negative 5 and 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So when we write our factored form, don't forget your GCF. Our GCF is negative x. And our factors are x minus 5 and x plus 2. Ta-da! How do we feel? Okay, this was supposed to be somewhat of an Algebra 1 review. I hope that some of this was taught in Algebra 1 and it feels like oh, I've seen this before. Okay, yes. All right, so our exit ticket for this, I want you to take 90 seconds to share with your table people, your group mates. Do you feel confident in today's lesson? And at the bottom of your page, be honest with yourself. How did you feel about it? Do you feel like you actually learned? Do you have questions? What are the questions you may have? Because sometimes we forget to ask those things. And so if there's questions or you don't feel confident on your page somewhere, write how you feel and go.